Hello and welcome. This is Birdy. I'm back. Today we will continue our journey in the art directing ocean in Houdini. Today we will separate the components of the white water in three parts: foam, spray, and bubble. So talk to the hands and let's get started. Hasta la vista, la baby. Now let's get inside the whitewater import and separate the three component of the whitewater. Okay, so first let's make blast. Let's make add spray bigger than 0. So and delete and select and choose point. Okay, if we so as we can see here now we separate all the only particle that has a spray bigger than 0. Of course, all the three component attribute for the white water, the spray, the bubble, and the foam. Every particle, of course, have the three. If we go this, every particle has the three attribute. All these three attribute. Of course, all of them have the same attribute, but in different value. For example, let me show you height wall attribute, show only bubble, foam, and spray. As we can see here, the spray in some particle is just 0. That means in this particle we don't have really a value for the spray, but later on when simulation happening and when the particles start to become, the splash is out of the fluid and started to have the spray shape or the spray function, so this value will change to become bigger number than 000. And as we can see here also, bubble has most of it is bubble because we are still all this particle under the surface of the fluid. Same as foam, it's on the surface, but there is still nothing for the spray yet. I still don't know why the computer is very slow, but I remember that we should change something here in the advanced. I usually uncheck the use OpenCL because my computer wouldn't able to handle the OpenCL. Also, maybe I can see here if I stop. Everything looks okay for me. To be honest, I don't know why it's very slowly. Something make the scene very slowly, but I'm not sure what is it. Okay. So anyway, now we have the spray. Let's Control C, Control V. Of course, let's name this spray. Now we separate the spray in this null. Let's call this bubble. And instead of writing spray, write bubble. Make sure you write it correct to read it. Now we separate all the bubble that has bigger value than 0. Last but not least, we'll have the last one, which is the foam. Let's name this foam. Also make sure that you type it. Oh, I forget the bigger. Don't forget to check the spelling of the attribute. Also you can see it from, of course we're not going to see it here, we have to go to the frame 2 to have and as I said earlier, if you want to check the spelling of the attribute, you can check it from here. Bubble, foam, spray. Okay. Oh, and also we have the veil mask that we did. Maybe we can delete it. Usually, sometimes we need to delete the not necessary attribute to make the scene goes faster. Okay, maybe this is why. Maybe we should do this earlier. Also, I would like to check something very fast from the fluid extent, just to make sure that I make the mask. Yeah, okay, looks good. Okay. In this process called cleaning, we clean the not necessary attribute. You can make a delete attribute delete. Of course, it will be on the top. We can make it like this and like this. And of course, this is from here. You can start to choose which. For example, we don't need the veil mask, of course. I don't think we will need the speed mask. We have a live form, depth, density, bubble, age. Okay, all of them we will need it. We don't have dop objects. Not sure if we going to delete need this one. Variable map, mixed dot pass construction. Not sure if we are going to need any of this. Construction schedule dot pass, next variable map. You know what? Delete all of them. So I will delete all of them. So this is the attribute that, if we check here, as we can see now, we only have this point. We have groups also. White water stream, just born. But this doesn't have a group. Maybe we can add another group delete here. I don't think we need any of this, so I'll delete them all. Delete unused group. Okay, so let's continue. If we check here now, we only have the attributes that we may need it. Okay, let's continue. As I was saying, now we separate the three component, and now let's continue to make the first render for the, let's say, maybe bubble. Okay, so now we are in the frame 10, but I want to say something. Maybe I figure out why the Houdini is very slow, because this version is 18.532, and I originally I started this project in the version 18.4, so maybe that's why when I open it in the 18.5 it becomes slowly. I don't know, maybe it's from the version itself, maybe from shifting from the file from 18.4 to 18.5, because really I cannot think in any other reason more more than this. So let's continue. Now we have the foam. As I said earlier, this big large of the foam, but looks okay. Okay. First of all, as we know, we made a flip tank. So this flip tank doesn't have the shape of. We made ocean flat tank. So this ocean flat tank doesn't have the shape of the wave, right? We added the wave as a displacement map only and a mask, but the particle itself doesn't have the shape of the wave, right? So it's most of it is flat. So to give it the shape of the ocean, we have to make another node. Of course, if we used this node or this node, we wouldn't have to make this step, but because we choose the ocean flat tank, we have to, if we want the particle to have the shape of the wave but still bubble under the surface, we will give it this new point VOP. Okay, very slow. Okay, I figured out just something. I will make it very quick. It's about the flip fluid extended. Maybe I can make some change on it just to make sure. Okay, make it like this. I will make it here only. Now it doesn't have to calculate any of this. Okay. So let's continue. Let's get here. Let's stand here in the point VOP. First we need an ocean called ocean sample volume. Okay, very slowly. Let's connect the sample with the sample position. Okay, and let's add it to the original position like this. Yeah, and this one, this big goes to the market, to the position, of course. Okay, now we will make some modification, promote file name, promote the mask name. Okay, we don't need the down sample. Looks good for now. Let's go back. We need the we need to type here or read the displacement file and the mask file that we render it. Of course, it's in the material itself. So let's go to material. Let's go to the ocean surface. Parameter. Yeah, this two. I need this two. Let's go here. Let's drag and drop both of them here. Geometry, relative reference. Yeah. Okay. I think it's become faster now. Maybe because of the flip fluid extent. Maybe that's why it was slow. Okay, so now let's check what we have here with or without this one. Without, oh, I'm sorry, without, with. As we can see now, the particle moves slightly. Now it has something cool, looks like wave, right? So now we give it the as if this bubble advected by the wave of the ocean. Okay, now next step, we need to scale it to make the render of the every particle is much smaller. Okay, but before I do this, let's first decide it. Are we going to use it to render it as a VDB, or we can render it as, yeah, I'm definitely sure the computer was slow because of the fluid extent, because I used to read here fluid extend, making caching in VTB and all this stuff. Okay, now maybe we can render it as a particle and give it a principal shader, not a VTB, but you can do both. Both can work. If you want to make it a VTB, you will simply connect it like this. If you want to make it as a particle, you don't have, maybe you just, for organization only, make this out. Since this is foam, okay, okay guys, since this is foam, I think it's better to render it as SDF. Okay, as we can see here, we don't have really to do anything here. It gives us everything that we need: the fade in time, the foam location, depths, and so on. And also here, if you want to change anything here, voxel, coverage, converge, all looks good. Okay, I'm not going to change any of this, but maybe we will play with the particle scale, the B scale. Okay, but first let's render it. Let's see what we which it has a white water material. Let's go to the white water. Yeah, here is the white water. Density scale, if you want to increase the density scale. Shadow scale, scattering phase. This scattering phase work, I think it allow the, no, this is the, yeah, allow the light to to get inside the volume itself and light it or illuminate it. Okay, so it's like more like subsurface scattering. Reflective intensity, if you want to increase the reflect intensity, reflect roughness as well. So maybe I don't think we need to make any change here. Just looks cool. Maybe if you want to increase the density for the scale, of course you can do all this with the widget to compare. Let's go to the out. Let's make a new mantra node. Call this foam. Let's go to the objects. Let's name this one as a foam. So this will be the foam. Okay, let's go back, and of course you can go to sample, no velocity blur. You can add velocity blur if you want to have motion what its name, yeah, motion blur. Yeah, if you like to add motion blur inside it. Okay, so we have the foam. We may go to the object. Now let's choose the foam that we are going to render it. Here it is. Accept. We will only render the foam to see it black and white. Let's choose camera 2. We are in the 10. Looks good. Let's go to the render view. Ah, let's choose the foam and let's see the render. So as we can see here now, the foam really looks very nice. If we zoom in, so it render it as a VTB, as I said, as a volume. And also, if you like to play with the B scale, uh, to be honest, I think it's nice. I don't need to change its B scale. It looks nice to me. Okay. So that was forget. So this was a form. Let's also render it with the surface. So let's add also the extent. Hit accept, and let's. Oh, it will render by itself. So as we can see here, it's very white. I would like to increase its intensity and maybe play with the B scale for a little. So let's stop it here, take a snapshot. Let's go to the material density scale. I think density scale looks nice. I don't have to do anything about it. Let's go to the object. Let's go here. Let's play with the B scale as I said. We'll add attribute randomization. Attribute randomize. Add it here. Let's a point. It's called B scale. B scale. Instead of set value, we will choose multiply. Let's multiply by 0.2. So the B scale value will multiply it in 0.2, so it give us like 20% size of the original size. Okay, that's a one dimension. Let's add seed attribute ID for not change the scale of every particle every frame, so it can recognize every particle and give it a subtle value in all the timeline for every particle. If we didn't choose the seed, it will change the size every time, every frame it will change the size. Okay, minimum value, maximum value, maybe 0.5 and 1.05. Also, if we maybe we can choose custom ramp to only focus the size in a specific area. First, let us render this one to see the difference. Let's hit render. So let's check it. Here's the file. As we can see now, I think this white is from the surface water itself. It's not from the yeah. And actually, it's made a very a horrible result. Very horrible result. I don't like. as result. So maybe I will cancel it. And also I don't like the B scale. Just stop it here. So I will cancel this attribute and also go to the material, ocean surface, and simply just get everything back as it was before, because I don't like I can multiply it in smaller number, but in general I don't like it. So integer, yeah, and the color also, this is the color. This is the color. Yeah. Output. So now let's render it again to see the different. So that was the result. Not sure, to be honest, but maybe just all I have to do is input density, maybe make it just like one. Let's re-render it again. Let's take a snapshot. Let's render it. And that was the end of this lesson. I hope you enjoyed. If you have any question, type it in the comment section below, and don't forget to like the video and subscribe the channel, or I will come for you. And of course, don't forget to support us on Patreon and Gumroad, and I will be back.